I'd like to welcome our last speaker on the new page of injection book, Memcached Injections, Ivan Novikov. Please welcome him.
Hi all, hi Blackhead, and thank you for coming. I won a super prize the last talk. So, does anyone know what is Memcached? Right, I am too. So, my short bio, I'm a CEO and a security researcher since the last 5 years, and also a bug hunter, just funny. And also, we must try to understand what is Memcached. Memcached is a very popular technology. It's a memory and cached, like as modem is a modulator and demodulator. It's really easiest nowadays to find anyone who knows what's Memcached than anyone who remembers what is modem. Right, Memcached is key value in memory database, and very popular for session storages, and it's obviously bad for caching different objects such as templates, for caching classic SQL responses and others. It also supports by all popular platforms and frameworks, and it's not so hard to find a Memcached driver, for example, for Erlang, for Ruby, for PHP, and much other frameworks and platforms. Shodan stats about Memcached. I use Shodan, I think you know what is it, to understand how Memcached are popular. And I think you can understand on this slide that in the wild internet you can find by Shodan 118,000 of opened Memcached ports. It's really bad because Memcached have no any authentication typically. In modern version, Memcached has SASL IOS, but I think 90% of this open Memcached are unprotected. It's most popular than Redis and MongoDB, as Shodan said us. So, in short protocol overview. Memcached use at transport layer TCP and UDP both. If you run Memcached daemon, this daemon opened TCP and UDP ports 112.1.1 both. It's 2 ports with different protocols. Memcached basically has host-based authentication, but in modern version also supports CASL. Plaintext and binary protocol exists in Memcached daemon both. A client can communicate with server by a plaintext protocol if client wants, and also by binary protocol. At this talk, I research only plaintext protocol for different reasons. And in the real-world applications, plaintext protocol is more popular. Plaintext protocol, it's obviously use classic CRLF delimiters. It's 10 and 30 bytes, and length of data filed must be put in argument and storage command. It's a really typical case. For example, HTTP do the same. 3 different types of commands present in Memcached. It's data operations and slaps and maintain operations. Data operations typically is storage operations, commands like a set, and retrieval operation command like get, deletion operation, increment, decrement, and operation to touch empty values keys. Also slaps. Slaps operations is techniques that provide us to reduce memory fragmentation problem. And also different maintain operations such as statistics operation, information services, and version checks. Just easy, and I think you know about that, but for future slides we need this. Applications, different applications use Memcached differently. Typical case, as I said before, is session storages, and session typically is serialized data, but not in each case, of course. And caching different data such as plain strings or serialized data, for example, objects, and commonly used to store different codes such as templates and macroses and other kinds of executable code. For that, it's really interesting to inject arbitrary code into Memcached values. How data stored at application layer? Basically, its key typically contains prefixes. It's application logic under main Memcached protocol. Namespace in key, it's just delimited by any bytes, for example, by slash namespace. It's string shards which provide application to use different application logic. And the key after prefix commonly depends on user's data. For example, from user's login, for example, from user's session ID or other user data. And for that, arbitrary key writing gain authentication bypass and bypass namespace restrictions by design, because it's not so good idea to inject arbitrary data in any database, and Memcached is one of them, right? So last, it's about Memcached wrappers. Memcached wrappers is a glue between application logic and Memcached daemon, Memcached protocol. Wrappers is, if you want a Memcached driver for framework for your environment. It's used for format protocol packet and do input validation, do length calculation and others. And for that, wrappers is our target. Application logic also, but if wrapper has a really good input validation, there is no way to make vulnerability in code. And for that, wrappers, Memcached wrappers for different platforms is target of my research. Wrappers also send and retrieve results and open sockets also, and control the sockets and write data to them and read data from them, right? And also process data. So example, do operations like data casts and operations like unserialization data and other. And the last slide about the introduction part is scope of research. I researched Python, Lua, Go, PHP, .NET, also Java and Ruby wrappers. That's all. I'm really happy like this cat because introductory part of my research completed. It's not so good idea to to talk more about Memcached. So that's time to practice, time to do something neat with the protocol and injections. All injections in Memcached can be classified by 4 types. It's a command injection, classic way to inject arbitrary commands in protocol stream. For Memcached, command delimiter is a typical plain text delimiter. As I said before, this only about plain text version of Memcached protocol, not about binary. And reason of this type of vulnerability is improper validation of commands delimiter. It's CRLF bytes, and it's really easy. Second type is state break. It's more complicated type and not so easy to understand. It's first time, I think. It's not so easy, right? It's invalid command invalid command feature, because in plaintext protocol, all plaintext protocols are state dependent. If you send an invalid command, protocol parser in the server side returns process state on a phase of expecting command. If your wrapper send data after invalid command, this data will be interpreted as a new command. Third type of injection types is argument injections. Argument delimiter in Memcached, the plaintext version, is a space byte. And also 0 byte may end any line of command. And the last type is a lens break, just only theoretical type, because I can't show any example vulnerable for the types of attacks, and this theoretical idea that null byte in data can break data calculation, data length calculation function in wrapper, but all analyzed wrapper are not vulnerable for that. So now about each type of injections in deeply, right? First is comment injection. Comment injection is driver any wrapper vulnerability consists of missed validation of command delimiters. It's A bytes and D bytes and hex view. This feature provides the attacker to inject arbitrary command after application command. And no other restrictions there, because you have no control this thing at application layer. Application only can read any keys and do any protocol operation. It's not so easy to validate arbitrary case by application side. Simple vulnerable PHP code listed at this slide. As you can see, Memcached class for PHP are vulnerable for this type of attacks. And second line is construct of a Memcached object. And then we set any key, and key index depends from user data, from URL key parameter. And exploit looks like this. We inject serialf bytes into key URL parameter, and after serialf puts a new command. It's a set command, highlighted dark color, and we inject new key with name injected, and set flag 0 and time to life 1 hour and length 10 bytes, and then put 10 bytes from 1 to 0 in injected key value. How it works in protocol level. And at protocol level, wrapper concatenated together our commands in one TCP packet and send it to server, and then server interprets this packet as different commands because server find serialf delimiters in state. It's really obviously for any plain text protocol. Who is vulnerable for this type of attack? It's Python. Python PyLib MC is vulnerable, and Python Memcache wrapper is not vulnerable. For PHP, Memcached D is vulnerable, and Memcache without D at end class is not vulnerable. And also custom Memcached.net project is vulnerable for this. I think time to show short demo about this. Moment. Nice. My first demo. Yeah, right. At this slide, this loop you can see simple vulnerable PHP code consists of simple Memcached class construction, and then set operation, set command depends from user data. In first argument, it's a key. And static data, 10 bytes there. Then our application read key with name of config, and then read key with name key1, and then put this information into HTML output for user. It's time to exploit it. Ta-dam! What we doing? Nice, code highlighter. Tintin. Yeah. Yeah, it's ugly web interface, but it's really nice to demonstrate basic of attacks, and there is no anything more. This is text area. Data from this text area puts into first argument of Memcached set function. Attacker can use this to overwrite arbitrary Memcached keys. Not so easy. Right. Up. Where is my? No video more. No. Sorry. Time to swipe. Mirror displays, it's more easy for me. Right, nice. Yeah, it's nice. So, this again, vulnerable PHP code. My really ugly web application. And this text area. Data from this text area puts into Memcached command. And now we put different data from this file and data file, and try to overwrite our static value for 10 bytes from 1 to 0 by arbitrary string BHUS 14th.
Bring the lights down so they can see the black screen easier.
Yeah, right. Screen mirror, right.
Here, but they'll see that better.
Yeah, right.
Okay.
That's nice. Thank you. So, and now it's you. Yeah, my mouse. Nice. Attacker puts only 1 byte, and then other arguments for set commands. It's a 0 flag, and then 1 hour time to life, and then 6 byte, because 6 bytes is length of string BHUS 14th. And then put it into driver, and you can see that key value changed from 10 bytes to 6 bytes BHUS 14th. So also attacker may inject other commands such as /all. Now try to run a TCP dump to view at NetFlow and understand what happens in that case. Send attack vector again, and our first byte, and then new command delimiter, and then put new commands, for example, a storage command set, and try to overwrite arbitrary key config, and also set set again flag 0 and then 1 how time to life and 6 bytes. I'm sorry, 10 bytes because BHUS 18 own string has 10 bytes length, and then send it to application and try to understand what happens. Yeah, key overwrite unsuccessful, and then try to find the TCP dump. It's protocol communication dump. Where is my set command? Yeah, right. I think you know that it's only one TCP packet, and then in this packet, 2 different protocol commands. First command is invalid. It said key without any data, without any arguments, and for that, Memcached can't pass that command and produce an error. And after that, our wrapper said second command because we inject this command in text area file. And after that, of course, Memcached wrapper must send data prefix from other data. Now we can look at Memcached daemon responses for our packet with our injected data. Scroll down, please. Scroll. No. Just highlighted something really useful. Yeah, this injection. I think you know. Then scroll, please. Scroll. Yeah, right. This is a response from first logic command from our one packet, only one packet sent from our application to Memcached. First response is error because first command has no any arguments, and for that it's invalid command, right? Response for second command, our injected command is valid response, and server said store it. One moment. Scroll, please, scroll. Yeah, store it. Nice. Our injection done. We inject arbitrary key config with arbitrary data without any restrictions. It's really nice. And then our wrapper sent last chunk of data. Of course, it's invalid command, and for that, Memcached daemon produce an error again. But all works. We inject command. It's pretty nice. I think time to run my favorite command from Memcached is flush all. As you know, this command flush all Memcached memory and produce application error for that. Application crashed, but we have now any keys more. Nice. This is the first demo and first injection type. Moment. Yeah. So not so easier. Not so easier type of injection is state breaking. As I said before, Memcached daemon provide us to plaintext protocol, and each plaintext protocol depends from command state. And for that, missed validation of command format, for example, key name or attributes count or 0 bytes validation, provide us to break this command and return state of Memcached command parser again to the face of interprets command. And for that reason, any data puts in a data file will be interpreted as a command, as a new command. And this is really nice to exploit because there are no any filtrations in data files. Just only database, and you can store in this database any data which you want, without any restrictions, without any encoding and others. This exploit again for PHP. I'm sorry. Sorry. Yes. Ta-dam. Yes. Ugly animation. This exploit again for PHP. We use 251 bytes in key to break state, because a lone key produces a memcached error. Memcached are not allowed to use lone keys, and for that, second argument v puts into data file will be interpreted as a command. Just easy. It's not NetFlow, but logic protocol response request dump. At first command, we put lone key and transmit and received error from Memcached, and then send in our data, but our Memcached server interprets this data as a new command, because command before is invalid, and then puts data. I think much more interesting to see not for PHP, time to exploit Ruby code. RubyGem Memcache is really popular and vulnerable for this. Simple code, Ruby language, and second line is initialization of Memcache wrapper, and then set data and get data back is key stuff. This example shows that 0 bytes also can break parser state. Ruby driver is Ruby wrapper driver is not meta. It's very interesting because developers of this driver do valid input validation for space bytes, for new line bytes, but not for 0 bytes. And for that, you can exploit it. As TCP dump of attacks presented this slide, you can see our 0 byte, which provide us to break first command and then any data and then new command in data file. You can see I prefix is serialization prefix because Ruby driver and Ruby wrapper always use marshaled objects to store. Even if you want to store integer or string value, not only for objects, Ruby driver always will marshal your object to serialized string. It's not meta for our kind of attacks. It's a protocol protocol dump, logic protocol dump, and of course /0 it's 0 bytes replaced to escaping only for presentation reasons. This command produces error because Memcache read first command line only before first 0 byte, and for that it is command without arguments. It's invalid command, of course. Memcache produces an error, then try to interpret serialization prefix. It's invalid, also invalid commands, and produce second error, and then read and try to interpret our data as a command, and because it is a valid injected string, Memcached successfully interprets this as a new command and returns stored. And last command was also invalid because it's Memcached RubyGem serialized postfix, and it's not looks valid Memcached command. But anyway, we do injection. We set arbitrary key stuff with arbitrary data to 10 arbitrary zeros. It's nice. Who is vulnerable? I think coverage larger than than first type of injection. It's Java meetup Memcached class, but not Java Spy Memcached. Also lower REST Memcached is vulnerable, and RubyGem Memcache, but not Ruby Memcache client, and no Daily. Daily used for example, by Ruby Rails, and it's popular. Memcached class for PHP is vulnerable also. Memcache without D on end class is not again, and Memcached.net project is vulnerable again. Time to second demo. This example, again, ugly web application, written in Lua, on Ruby, and CGI. It's more easy for me to run anything in CGI. Filed item no is filed for keys, and filed data is filed for protocol data. We can put anything in data and store it by item 1 and look this test string on HTTP response. Application really simple. First line is driver initialization again, then this application set arbitrary key with prefix item, and postfix depends from user data from item no URL parameter, and then put out data from Memcache to HTTP output. Yeah, time to inject 0 byte to break syntax, to break parser state, and we do that. Ruby wrapper produced error for us, and then contains very sensitive information, but this sensitive information not fun. Yeah, as I said before, Ruby Memcache wrapper always use serialized value, and for that, to store our arbitrary data, we first needs to serialize it by Marshall. I use simple Ruby script in one line to serialize any data, for example, 1 to 3 string into valid object to store, and then simple copy it and put into data. After, of course, serialf delimiter and set command and key stuff, 0 flag, and 1 hour time to life, 60 bytes, again delimiter, and set it into my application, and refresh page to view results. Yes, we successfully inject arbitrary data into key stuff. Time to look at TCP dump, I think. No? No, time to set bhus on u string into Memcached. 13th, of course. It's 24 bytes length, and the commands look same. Just easy, really easy to inject arbitrary case in Memcached. Yeah, success. Nice. Now, key stuff has data bhus 40 on you. So, time to run TCP dump again. And repeat our attack vector. And look at TCP dump. Where is our packet? Here it is. Nice. Where is our null byte? Null byte, where are you? I find it. Yeah. It's a new line command in data file, and this is a 0 byte which break parser state and a list of several responses. First error and second error, and so to store it, it's a response for our valid command and that error again, because last prefix from serialized data isn't valid command for Memcached, but anything all works as we expected. And then flush all. It's really nice command. Not for production environment, but really nice to check. Flush all. No. Flush all again. Yeah. Now we have empty data by index stuff, by index item 1 also. No data, no problems. Injection here. All right. Time to returns again to different injection types, and third types is argument injection. Argument injection is really same as first type, but reason of this vulnerability is improper input validation, improper validation of argument delimiter. It's a space delimiter, and for that attacker can do something like argument shift, because, for example, set commands has a optional last argument, and if you can inject your data as new argument, last argument and the arguments before shifted on one position right. So how it works? It's attack vector. We inject only one byte. It's a 0, no, not 0 byte, but 0 cipher, and then put it into Memcached. And now it's really neat, because now we inject 0 as a 0 flag, and 0 flag becomes now a time to life, and length of data becomes time to life, and time to life becomes length, and and time to life becomes optional argument. And for that reason, we can we can inject data to make packet valid. It's flat data, and then insert new command in protocol stream. It's one way to exploit, and the same as first type of injections. Python is vulnerable, Memcached for PHP vulnerable, and .NET vulnerable. It's not interesting, I think, but I have something interesting at last. It is not lens breaking, because lens breaking just only theoretical issue. Theoretical issue is just concept and never found. But I suggest then null bytes in data file can break in different cases, and maybe it's not often cases, but anyway, it's possible to break calculation length of data, and for that, part of data filed can be interpreted as new command. So it's my concept, but never find, and no platforms vulnerable for that. So it's potential exploit, but never works. Exploit, yeah. So last idea is post-exploitation. As I said before, Memcached wrappers provides us not only for socket communication, not only for data receiving and data transmission, but also data manipulations and, for example, cast data and then serialize data and other. And the deserialization process, arbitrary data is also not so good idea, and it's a CVE 502 number and the common weakness enumeration database. For that we try to exploit it. Application layer plays this because we can execute arbitrary memcached command and can read arbitrary data from application layer, and for this reason we can try to inject serialized data which must be deserialized by application at reading data process, right? There are two types of deserialization exploits. First type is effects where effect depends from application code. It is Java case and PHP case, Ruby case, and the custom frameworks like Symfony, Rails, and others. But Python, it's really nice because Python provides us to independent code execution in pickle deserialization process. A few years ago at Black Hat, somebody described pickle formats in deeps. So, time to my last demo. It's remote code execution demo in Python. We have, again, ugly web application, Python web application, this code, simple code, content type setting, and manipulation with with only one user data from store ID URL parameter, construct again interface on loopback interface in cache driver, and then put any data there. We can put in item 1. This is this is view on Memcache serialized data pickle format with back shell inside process. It's really easy to execute this, and only I think 100 bytes needed to do that. Just a pickle provide us this function, and for execute code we need to inject any key which be read by application. For example, a config key or something other often read key. We open back shell on the loopback interface and on port 12345 and run shell for this, and redirect descriptors to make our shell interactive, right? Compile this and put into our memcached vulnerable file. This is my last demo. This is my last minutes of my talk. What happens? I need a shell. Please. I need to listen this port before, right? Run netcat on port 12345. Send again, and yes, we have a shell. It's easier way to exploit Memcached wrapper as remote code execution for Python case. Yeah, we www user, www data user. All works as we expected. Pickle the best, and Python not. And there are no TCP dump. For this video, I think you can suggest what this looks like for. So, what's the conclusion? What's the reason of my talk and this exploits? Please use binary protocol. don't use plain text protocol for Memcached. It's not so good idea to communicate with any server by plain text protocol, and for that reason, HTTP I think also must die. Our stats. Yes, I like SPDI. So stats. Researched the 2 drivers for Python, and one of them are vulnerable. 1 driver for Python and vulnerable, and 0 of 1 wrappers for Go vulnerable, 1 of 2 wrappers for PHP vulnerable, 1 of 1 for .NET, 1 of 2 for Java, 1 of 3 for Ruby. And what's the reason? Hamster win. Go said us that it's champion. So, I talk only about Memcached wrappers, not about application, because coverage of applications are really huge, and most of them are not fixed yet, and I'm still waiting for that. So I'm finished. Thank you. And if you have questions, we have a time for that. Thank you.
Grails, yes. Grails.
Rails, Ruby on.
Grails.
No, there's no matter which framework you use, because frameworks just use any wrapper. For Ruby, I found only 3 wrappers, and I have no ideas which of them use it in Rails.
Okay.
You can check it. It's really easy.
Yes, I just want to make sure that I understood that all of those attacks were based upon injecting values into the key, and that there are no successful attacks that you've found so far that are value only based.
Right. Thank you. All working attacks required injections in key, but not. It's really required. But you can put your payload in data if you can break something in a key file.
Right.
Yeah. Not for payload, but for break and state always.
Okay. Thank you.
Yeah.